Hello students, in the last video we have seen few simple examples of triple integration. Now in this video we shall discuss the examples of the triple integration which are able to find out the volume or some quantities which is in fourth dimension. So let us start with this exercise. The exercise is find the volume of the solid bounded by the paraboloid z equal to 4 minus x square minus y square and xy plane. Now let me discuss first that how we are working in double integration and how we are going to work in triple integration. So in double integration we had a region, right? Then we have to write the limits for x to y or y to x. I mean dx dy or dy dx. Suppose I assume that I am writing for dy dx, then what we are doing? First we find what is my region. Then in my region I draw the vertical line, right? Then I take the projection of the region on x axis. If I am writing for dx dy, then I draw horizontal line and I write the inner limit. Then for the outer limit I take the projection of the region on y axis and then we write the limit of y. The same concept we apply to write the limit in 3 dimension. How do we apply the same concept that we are discussing in this exercise? As you know, volume of the solid S is triple integration of the function 1 with respect to z, y and x, that is dz dy dx. Then what I have to do? I have to write the inner limit of z, then the limit of y and then the limit of x. Now see, when I write the limit of z, what is my first task? I have to observe my solid, that the structure which is bounded by the surfaces, right? Once I am not sure about that structure, I am not able to write the limit of z. So the first task, let us draw these curves z equal to 4 minus x square minus y square and xy plane. You know what is the equation of the xy plane? The equation of the xy plane is z equal to 0. So I have to draw two curves. One is z equal to 0 and another one is z is equal to 4 minus x square minus y square. So let us draw these two surfaces first. Here red color axis is x axis, green color axis is y axis, and this is the blue color vertical axis which is z axis, and this is the surface z is equal to 4 minus x square minus y square. Just observe this surface, z is equal to 4 minus x square minus y square. Now the another surface is z is equal to 0. So let us draw z is equal to 0. Z is equal to 0 is nothing but the xy plane. So this is our xy plane. See, this is z equal to 0, right? The blue color plane. The xy plane is. Now what we have to do? Let me show you in this way. So this is z is equal to 0 plane and this is our surface z is equal to 4 minus x square minus y square. Now whenever we are writing the limit, what we were doing in double integration, whenever we were writing the limit of y, we walk vertically from bottom to upward direction. The same thing we do here. First we try to cover the z axis because first is with respect to z and z is the vertical axis here, right? So we always walk negative to positive direction. So when you walk in this way, first we enter in our solid from the plane z equal to 0, and when we move inside the solid, then we exit from the surface z is equal to 4 minus x square minus y square. So this is obvious that z equal to 0 will be my lower limit and the upper limit will be z equal to 4 minus x square minus y square. So let us mention it first. Z equal to 0 to z equal to 4 minus z is equal to 4 minus x square minus y square. So these are the limits of z. Now we have to write the limits of x and y. But for this particular example, right now I am not writing the limit for x and y. I am starting the evaluation of this example. Right. Let us see what is happening. So this is equal to integration x is equal to integration y is equal to. Keep in mind, intentionally I am not writing the limits of x and y because I want to explain something. What is the integration with respect to z? Is z. What is the limit? The limit is z is equal to 0 and z is equal to 4 minus x square minus y square dy dx. And so this is equal to integration x is equal to integration y is equal to, substitute the limit of z, upper limit z is equal to 4 minus x square minus y square. So this is 4 minus x square minus y square dy dx. Because when the lower limit z equal to 0, everything is 0. So this is only 4 minus x square minus y square. Now concentrate here only. We have already integrated with respect to z. So the remaining quantity contains only x and y. That means now we have to concentrate on xy plane. See, in double integration, when we drew the vertical line, we have written the limit of y. Then what we are doing? We took the projection of the region on x-axis. Here what we do? We take the projection of the solid on xy plane. So now let us observe that how the projection looks like. Now see, I am taking the projection of this on xy plane. So this is the projection on xy plane. Right. This green colored circular disc is the projection of z equal to 4 minus x square minus y square on xy plane. Right. So these are the intersection points. This is circle with center 0 0. Now when we take the projection on xy plane, that means z is equal to 0. So when you substitute z equal to 0 here, 0 equal to 4 minus x square minus y square. What does it mean? X square plus y square equal to 4. So that is the circle with center 0 0 and radius 2, because x square plus y square is 4. 4 is what? 2 square. So this intersection point is 2 0. This is minus 2 0. This is 0 comma 2 and this point is 0 comma minus 2. So now the projection gives me the region. Now this is my region, right? And for this region, how do we write the limits? This is dy dx. So two options we have. Either you draw vertical line or you rewrite this dy dx in dx dy. So draw horizontal line and then write the limits of y. But here what I am doing, this is the circle x square plus y square equal to 2 square. I am converting this quantity in terms of polar coordinates r and theta, right? So what would be the limit? R starts from 0 to onwards, r will go to this, right? And then what is theta? Whole circle we have given, so theta will be 0 to 2 pi. That is obvious. Again I repeat, r starts from origin always, so 0 to, I have to cover all circle 0 to 2, right? And theta is 0 to 2 pi. Clear? Let us mention it. Now the question is how we write these in terms of r and theta. So here now I make this change, that for these two integral, my region lies on xy plane, so I write rxy. For these two integrals, I write my region on xy plane, and the same thing will be continued here. my region on xy plane. So this is equal to double integration 4 minus what is x equal to r cos theta, y equal to r sin theta. So this is 4 minus r square. What is dy is r dr d theta. Now you know, I already told you what is r. Starts from origin and goes to 2. Right. What is theta? Theta starts from 0 to 2 pi because I have to cover full circle. And so this is equal to integration theta equal to 0 to 2 pi. Integration r is equal to 0 to 2. This is 4r minus r cube dr d theta. And so this is equal to, now see here r and theta are independent, right, because the limits on r is 0 to 2 doesn't contain theta, so I can integrate independently. So what is the integration of the quantity with respect to theta is theta with the limit theta equal to 0 to 2 pi. And what is the integration of 4r square is 4r. What is the integration of 4r? 4r square divided by 2, which is 2r square, minus integration of r cube is r raised to 4 divided by 4. So this is r raised to 4 divided by 4 from r is equal to 0 to 2. And so this is equal to theta is 2 pi minus 0, which is 2 pi, into when r is equal to 2. 2 square is 4, 4 into 2 is 8, minus 2 raised to 4. What is 2 raised to 4? 2 into 2, which is 4, again into 2, which is 8, into 2 is 16. 16 divided by 4, which is 4. And so this is equal to 8 minus 4 is 4. 4 into 2 pi is 8 pi. So 8 pi is the volume of the given solid. I repeat the exercise. What we have done, first I observe Z. I walked vertically from negative to positive direction. So I entered into my solid from Z equal to 0 and I exit the region from the surface Z equal to 4 minus x square minus y square. Now we integrate the quantity with respect to Z. So everything is in terms of x and y, and then we took the projection of the solid on xy plane. Here you may have one question, that what happens if I write the limit of z, y and x at the same time, right? So let me explain that situation also. Could you visualize what was the projection on xy plane? This was the projection. Actually this was the projection, right? Now I have to write all these three limits in terms of x, y and z. So this is integration. I am writing this limit z is equal to 0 to 4 minus x square minus y square. There is no change, right? Because this we have already mentioned. How to write z limit 0 to 4 minus x square minus y square. Now I have to write here the limit of y and the limit of x. What is y? I have to walk vertically. So I am entering into the region from this curve and exit from this curve. So if you draw the vertical line, then we are entering from this curve. What is the equation of this curve? X square plus y square is equal to 4. We are going inside the region and we exit from this curve. What is the equation of this curve? Again x square plus y square equal to 4, right? So what is y here, because I have to write y is equal to, so what is y here? Y square is 4 minus x square, so y is plus or minus under root 4 minus x square, and the same equation is here, y is equal to plus or minus under root 4 minus x square. Now see, we are entering, which quadrant is this? This is the fourth quadrant, and in fourth quadrant y is negative, so I choose minus sign. Clear? We exit in this quadrant, second quadrant, in the first quadrant. In the first quadrant y is positive, right? Or you exit from here, this side. This is the second quadrant, right? So this is the portion where y is positive, and so I choose y is equal to under root 4 minus x square plus. So my entry becomes lower limit y is equal to minus 4 under root 4 minus x square to y is equal to under root 4 minus x square. Clear? Now what? Take the projection of this region on x-axis, that is how much portion of the x-axis covered by the region. So this is the portion from this point to this point. This point is what? Minus 2 to this point 2, right? So x is equal to minus 2 to 2. These are the limits with respect to z, y and x. You can, choice is yours. You may go by this way or you may go by this way also. What is the exercise here? Evaluate triple integration of this function 1 upon x square plus y square plus z square raised to 3 divided by 2, where S is a solid bounded by two spheres, x square plus y square plus z square equal to s square, and x square plus y square plus z square equal to b square, where a is greater than b. That means this sphere has larger radius, this sphere has smaller radius. So this is the big sphere and this is the small sphere. Both the sphere are having center 0 0 0. This is radius a, the center 0 0 0 and radius b. So the first thing, how does the sphere looks like? See, this is the sphere with radius b, and this is the sphere with radius a. This is the red colored sphere is the larger with large radius, and this one with small radius, right? And that's why whenever I am drawing the large sphere, right, then the small sphere is going to inside, and that's why due to the some color reflection the color is changing, right? So here the black colored portion is this one, is the inner sphere, and the red color is the outer sphere. What I have to find out? I have to find out the volume. No, so I have, what I have to find out? I have to find out the triple integration of this function, and with respect to solid, what is the solid I have given? This portion, the middle portion, right? That is the outer part of the inner sphere and inner part of the outer sphere, right? So that is this portion. How do we write the limits? Once we write the limit, the second question arises is, are we able to integrate hard quantity with respect to z, then with respect to y, with respect to x? So here what we do, in double integration, whenever we face this kind of situation, then we use the change of Cartesian coordinates to polar coordinates. Now here we use the same concept, but here polar coordinates will not help because polar coordinates are defined for 2 dimensions. Here we use spherical coordinates. So do you know which are the spherical coordinates? Let me explain the spherical coordinates first. Then we discuss how do we write the limits. I have mentioned here the relation between Cartesian coordinates and spherical coordinates. The spherical coordinates are rho, phi and theta. The Cartesian coordinates are x, y and z. What is theta? 0 less than or equal to theta less than or equal to 2 pi. And what is phi? The range of phi is 0 to pi. The first thing, I am not going to explain how these formulae are derived, but I shall explain that what is the meaning of the range of this theta and the range of this phi. So see, how do we construct the sphere? That is important. See, observe this. What is this? So you may consider this as circle, right? This is the circle. So when do you draw the circle, what do we have? We have radius r, right, and theta. So for this full circle, right, say the radius is r and the angle is theta. So what is the range of theta? Theta is 0 to 2 pi, right? Now when I want to construct the sphere, what I have to do? I have to rotate this, right? So I have to rotate this in this way. Clear? With respect to its center. So this is its center, right? And with respect to that I rotate. So now you observe that when I rotate this, right, this is the front part and this is the back part. This part, when this part will come to this side, at the same time the back part will come to this side, right? So that means when we draw the circle, we need full angle 0 to 2 pi, but to construct the sphere we need only half rotation from this to this, right? Corresponding to this, the back part will automatically comes to this part. That's why, so for this rotation we need only half rotation of the circle, and so which represents angle phi, 0 to pi, right? To construct this circle we need full angle, that is described by theta, 0 to 2 pi. Is that clear to everyone? So what is the radius? Radius of this sphere from center to this is rho. So x is equal to rho sine phi, then cos theta, y is equal to rho sine phi sine theta, x and y, right, which is our given circle on xy plane, right? That's why here we have cos theta and sine theta. X is equal to r cos theta, y equal to r sine theta, remember it, right? So x equal to something into cos theta, y is equal to something into sine theta, and for this theta we need full circle. So 0 less than or equal to theta less than or equal to 2 pi and z. So vertically we are rotating it, right? Only half rotation we need, so 0 to pi, and z is equal to rho cos phi. Now here what we have given? Here we have given two spheres. So first, for the inner sphere, my radius is this, radius is b, and for the outer sphere my radius is a. Clear? So what I have to do? From inner to outer, only this portion I need to consider, right? So my radius will starts from b and up to a. So how do I write the limits now? My radius rho is equal to, my radius rho starts from b and ends at a. What about the others? We have two more variables, phi and theta. What about phi? Phi is the half circle, half rotation, right? So here phi is equal to 0 to pi, And what is theta? Theta is full circle, so theta is equal to 0 to 2 pi. Then what is x square plus y square plus z square? X square plus y square plus z square is rho square whole raised to 3 divided by 2. Now the question is, what is ds? So something which I am mentioning here and you need to memorize it, right? So for these coordinates x, y and z, we know that rho is equal to under root of x square plus y square plus z square. Or you can write rho square is equal to x square plus y square plus z square. That is not difficult to prove. Just take square of each variable and take its addition. So easily you can find out how rho square is equal to x square plus y square plus z square. Then dx, dy, dz, by the transforming of variable, this becomes d rho, d phi, d theta, and then the extra quantities from the Jacobian is coming rho square into sine phi. So in place of dx, dy, dz, which is our ds, you have to write down rho square into sine phi, d rho, d phi, d theta. So let us write down it here. Then this is d rho, d phi, d theta. So first I have to integrate with respect to rho. What is this quantity? This is equal to, so now let me mention what is ds. My ds is rho square into sine phi into d rho, d phi, d theta. Now this is equal to, theta is equal to 0 to 2 pi, phi is equal to 0 to pi. Now rho square, its square root is rho, so this is rho cube. Rho square divided by rho cube is 1 upon rho. So this is 1 upon rho into 1 upon rho into sine phi one upon rho into sine phi d rho, d phi, d theta. Now let us integrate 1 upon rho with respect to rho first, right, because the inner limit of rho, right? So let us integrate it with respect to rho first. So what is the integration of 1 upon rho? That is ln rho. So this is equal to integration theta is equal to 0 to 2 pi, phi is equal to 0 to pi. The integration is ln rho from rho is equal to b to rho is equal to a into sine phi d phi d theta, and therefore this is equal to integration theta is equal to 0 to 2 pi, right? What is this quantity? We substitute rho is equal to a and rho is equal to b. So this is equal to ln a minus ln b. this is the constant quantity. I can integrate sine phi with respect to phi. So what is the integration of sine phi is minus cos phi. I am integrating it here, minus cos phi, from phi is equal to 0 to phi is equal to pi d theta. So this is equal to, this is the constant quantity ln A minus ln B into this minus sign I am taking outside, so which is here. Now when I substitute theta equal to pi, this is cos pi. You know what is cos pi? Cos pi is minus 1, minus sign for lower limit. When phi is equal to 0, cos 0 is 1, into, now this integration theta equal to 0 to 2 pi with respect to theta is theta, from theta equal to 0 to 2 pi, and so this is equal to this quantity ln A minus ln B. You know this is ln A divided by B, so this is ln A divided by B. This quantity minus 1 is minus 2, with this minus sign it is plus 2. When you substitute theta equal to 2 pi, this is 2 pi, theta equal to 0, then minus 0, so remain as it is. So this is equal to 4 pi into ln A upon B. This is the answer of this particular triple integration. I repeat the exercise. What we have done here, we converted the Cartesian coordinates into spherical coordinates. When you convert the Cartesian coordinates into spherical coordinates, then this ds, which is dz dy dx, or any combination of dx dy dz that we have already seen in the last video, right? So this ds will be converted into rho square sine phi d rho d phi and d theta for the whole sphere. What is the limit of phi? 0 to pi, and theta is 0 to 2 pi. How these two values are coming, 0 to pi and 0 to 2 pi, that also we have discussed. On xy plane we have given circle, so theta is 0 to 2 pi. We are rotating the circle only from 0 to pi. Clear? And this is the radius of the two spheres, so from B to A. Here what is the exercise? Evaluate triple integration over S square root of x square plus y square plus z square ds, where S is the solid bounded by the plane z equal to 3 and the cone z equal to square root of x square plus y square. So what is the first task? Let us draw this surface z equal to square root x square plus y square and the plane z equal to 3. Then see, this is x-axis, green color is y-axis, and this blue colored, here it is shown, is z-axis, and this portion is our cone. Z is equal to square root of x square plus y square, right? See, if you take square both sides, z square equal to x square plus y square, then this below portion is also the part of our surface, right? But here we have given only positive value of z. Z is equal to square root of x square plus y square. This is the positive value, right? And so only this portion, right? This upper side portion, this is only our cone, right? Now the plane z is equal to 3. So this is the plane z is equal to 3. So what is my solid? The cone starting from the origin and till z is equal to 3. So only this is the portion of my solid. Now the question arises, for this particular solid, how do we write the limits? So what is the first task? We write the limit from down to upward direction. But here if you observe the quantity square root of x square plus y square plus z square, which may be difficult to integrate when I use the usual but see, here I have given the quantity square root of x square plus y square plus z square, right? If I write the limit with our usual aspect, then it may be difficult to integrate square root of x square plus y square plus z square by substituting the limit, and it may becomes more difficult. So what we do, we convert these coordinates in terms of spherical coordinates. So in spherical coordinates, what we do, x square plus y square plus z square is equal to rho square, and so square its square root, which is rho. Then what is ds? ds will be rho square into sine phi, then d rho d phi d theta. The question is, which are the limits for rho, the limits for phi, and the limits for theta? These three questions we have. So let us see what is rho. The solid is now clear, that z is equal to square root of x square plus y square, and this is the plane z is equal to 3, right? Now the first thing is, let us write down z is equal to 3 and z is equal to square root of x square plus y square in terms of rho, theta and phi. So when we have z is equal to 3, what is z in terms of rho, theta and phi? Z is equal to rho cos phi is equal to 3. What does it mean? Therefore rho is equal to 3 upon cos phi. Cos phi is sec phi, therefore rho is equal to 3 times sec phi. Rho is equal to 3 times sec phi. This is the equation of z is equal to 3. We have given another, z is equal to square root of x square plus y square. So can I write that is nothing but z square is equal to x square plus y square? If I take square both sides, then. Now what is z square? Z square is rho square cos square phi. What is x square? Can you tell me? See, what is x? X is equal to, what is y? Y is equal to rho sine theta, rho sine phi sine theta. So if you take x square plus y square, then x square plus y square becomes, see, rho square sine square phi cos square theta, rho square sine square phi sine square theta. So if I take rho square sine square phi common, then what will happen? Cos square theta plus sine square theta, and you know cos square theta plus sine square theta is 1. So x square plus y square is equal to only rho square sine square phi. That I substitute here. So rho square cos square phi is equal to rho square sine square phi. Rho square cancel out from both sides. Therefore cos square phi is equal to sine square phi. So I have two situations. Either cos phi is equal to sine phi, or cos phi is equal to minus sine phi. Now when cos phi is equal to sine phi, what is phi? Phi is equal to pi by 4. Clear? The angle where the cos and sine both are having same values, and therefore phi is equal to pi by 4. What does it mean? The equation of this curve is phi is equal to pi by 4, and this curve is rho is equal to 3 times sec phi. And this is very much important observations whenever we have to write rho, phi and theta. Now what is rho? Rho is radius of the sphere, right? So if the sphere is very much small, then radius is very near to 0. So in my region, right, radius rho is start from origin, rho equal to 0 to, I have to go till this. Rho is equal to 0 to this one, this plane, blue color, z equal to 3, right? So rho starts from 0 and rho starts from 0 and goes to this plane. So what is the equation of the plane? Rho is equal to 3 sec phi. So let me mention first, rho is equal to 0 to 3 sec phi. So I am writing here, rho is equal to 0 to rho is equal to 3 times sec phi. Now the question is, what is the angle phi? As I told you, what was phi when I have given the actual sphere? So phi was starting from 0 and we rotate it, half rotation, right? But here we are informed that my rotation starts from 0. 0, that means the positive z axis, right? When phi is equal to 0, it is positive z axis. So my rotation starts from this positive z axis and it has to rotate up to till only, right? And what is the equation of this curve? Is phi is equal to pi by 4, that we have already derived. So phi starts from 0 and up to pi by 4, right? Now what is theta? What is theta? So if we observe this region on xy plane, right, then on xy plane I have full circle, right? Whole circle I am visualizing, and so for whole circle what is my theta? 0 to 2 pi. And so here theta is equal to 0 to 2 pi. So this is how we are writing the limits. I repeat, rho is equal to 0 to 3 times sec pi, phi is equal to 0 to pi by 4 and theta is equal to 0 to 2 pi. Now let us integrate this quantity. So now this is equal to, theta is 0 to 2 pi, phi is 0 to pi by 4. This is rho into rho square is rho cube, which has integration rho raised to 4 divided by 4 from rho is equal to 0 to rho is equal to 3 times sec phi. Theta is equal to 0 to 2 pi, phi is equal to 0 to pi by 4 when rho is equal to 3 sec phi. This is 3 raised to 4 sec raised to 4 phi divided by 4. When rho is 0, then it is 0. So into sin phi d phi d theta. So now 3 raised to 4 divided by 4 is the constant quantity. So 3 raised to 4 divided by 4, theta is equal to 0 to 2 pi. Now the question is, can we integrate sec raised to 4 phi into sin phi d phi d theta? How do we integrate this quantity? So sin phi sec raised to 4 is what? 1 upon cos raised to 4 phi d phi d theta. Clear? So suppose I assume that cos raised to 4 cos phi is equal to t. Suppose I assume cos phi is equal to t. Then what is the derivative of cos phi? It is minus sin phi d phi is equal to dt, and therefore the integration sin phi, and therefore the integration sin phi d phi. So sin phi d phi is what? Minus dt. So that is minus dt divided by cos raised to 4. So what is cos raised to 4? Is t raised to 4. Right. This is nothing but minus integration t raised to minus 4 dt, which is equal to minus t raised to minus 4 plus 1 divided by minus 4 plus 1. So this is equal to minus 4 plus 1 is minus 3. So that minus plus. So this is 1 upon 3 and t cube. What is t? T is cos phi. So this is nothing but 1 upon 3 cos cube phi. That is the integration. 1 upon 3 cos cube phi. Right. So this is equal to 3 raised to 4 divided by 4. I have to write here phi is equal to 0 to pi by 4. Right. Now theta equal to 0 to 2 pi as it is. What is the integration of sin phi upon cos raised to 4 phi d phi? That we have already seen here, which is 1 upon 3 cos cube phi. So this is 1 upon 3 cos cube phi over the limit of phi. Phi is equal to 0 to phi is equal to pi by 4 d theta. And so this is equal to this 3 we can take it outside. So 3 raised to 4 divided by 3, which becomes 3 raised to 3 divided by 4. Integration theta is equal to 0 to 2 pi 1 upon cos pi by 4 whole cube minus, when phi is equal to 0, 1 upon cos 0 is 1 cube d theta. For your understanding, I am writing all the steps. So this is equal to 3 cube divided by 4. What is 1 upon cos pi by 4? First, what is cos pi by 4? 1 upon root 2 whole cube minus, this is 1. Now what is the integration with respect to theta? Is theta from theta equal to 0 to 2 pi. So this is equal to 3 cube divided by 4 into, see, this is 1 upon root 2 whole cube is root 2 whole cube minus 1 into 2 pi. If you want, you may simplify this quantity. This 2 will be cancelled out with this 4. So this is 3 cube is 27 divided by 2 into this quantity. Square root 2 cube is square root 2 square is 2. So this is 2 root 2 minus 1 into pi. I repeat, what was the much important thing in this exercise is how do we convert. What was the much important thing in this exercise is the first, write z equal to 3 and z equal to under root x square plus y square in terms of rho, theta and phi. Then the limit of rho is 0 to 3 sec phi than the limit of phi. That is also important. Phi is equal to 0 to pi by 4, and then when we take its projection on the xy plane, then we observe that it is whole circle, and so theta is equal to 0 to 2. In spherical coordinates, in this way we can convert difficult integrals into simple format. I hope you are enjoying the videos.